Welcome to this screencast. In this screencast, I'll be talking about recursion in Ruby, factorial, and the Fibonacci numbers. These two are very common questions in the interview. So I'll quickly show the solution and how I arrive at this solution. Okay, I have a test here which actually calculates the zero factorial. Zero factorial is defined as 1. So when I run this test, 1 expected but was nil, so I'm going to make this test pass. Just return 1 and make it pass. It passes, and then the next second test will be 1 factorial is 1. So here I have 1 factorial is 1, and this thing okay, I need to refactor this thing into the setup method. So I have a setup since I need it for all different scenarios. So I have instance variable, and I use that instance variable to access it in all the different tests. So let's run this thing. It has to pass because I'm just returning 1 regardless of what's being passed right now. So the next test is 2 factorial is defined as 2. So I have 2 factorial. I'm expecting 2 as a result. This will fail. 2 expected but was 1, so I need to fix this. So what I will do is if n is less than 2, return 1, else return 2. That's it. Now the test should pass. It passes. So the last one that will catch all cases is 3 factorial. So 3 factorial is 6. This should fail. So if you see the pattern that is emerging, 2 factorial is nothing but 2 times 2 minus 1 factorial. 3 factorial is 3 times 3 minus 1 factorial, and so on. So in recursion, there is 2 things you need to be aware of. It's the base case. I like to think of it as exit condition. Otherwise, if you don't have exit condition, it will loop forever. So base case is a subtask that a recursive routine can perform without calling itself. And the recursive case is routine calls itself. So in this case, it's going to be, we saw the pattern that emerged, so we're going to call same thing with n minus 1. So now implementation takes care of all scenarios and it passes. I've just ignored the negative scenario because negative values have 1, so this condition takes care of it. So now let's see how we can do the Fibonacci numbers. So I have a test for the Fibonacci numbers. I have setup method. So you have 1, 2, 3, 4, 5. These are the elements. First, second, third, fourth, fifth, and so on. As n takes on these values, the result will be this. First element will be 1, the second element is 1, and then you add these two to get this number, third element, and then you add these two to get the fourth element, and so on. So the first element is 1, so I'm just going to return 1. When I run this, it should pass. And the second one is Fibonacci of second element, as you can see, is also 1. So it's going to pass again. I'm not doing much. So the third element is going to catch all the cases and force me to implement This will fail. 2 expected but was 1. By this time we can see the pattern that has emerged. We add the previous two numbers. So the base condition in this case is if, and by now we know this, if it takes 2 or less than 2 we need to return 1, otherwise the recursive scenario is we need to add the previous two elements, which is n minus 1 plus fib of n minus 2. And let's run this test again. And it passes. So Fibonacci, this implementation actually you need to be aware whenever the recursive solution is used, the performance is slower. So you can rewrite the same thing using non-recursive equivalent way of solving the same problem. So in this case it would be something similar along the lines of this will be the result, 2 dot up to that nth element. I'm going to loop through each and multiply all the values. X, and then this will be returned. Let's run the test again. Actually this is factorial. So let's go to the factorial implementation. This is the implementation for factorial. So instead of doing this, we can do a recursive solution for this. So delete, and let's run the factorial again, and it works. And the old implementation, which is slower, also works. So thanks for watching, and if you found this screencast useful, please recommend me on working with Rails. Thank you. See you next time.